It is God's love.
Good afternoon. My name is Sajan. I work with Juniper Networks, and I want to thank Chair Mr. Jha and the eminent panelists. I think we have come into a time of discussion on the Digital India, which is a very ambitious program. We know that it began way back in mid-90s when our telecom revolution started taking place in India. And that changed the entire landscape. Probably we are the number 2 in the world around the number of mobile phones and mobile connectivity in the world. I think it's a great stride, and we have taken that very bold step. And that has changed the social fabric of India in many ways than one. So I will just, given the lack of time, I'll just quickly go through some thoughts. Of course, there's not enough time to establish any specific technology or solution in the light of NOF and BharatNet, but there are several things which will play together to bring the entire India being digitized. This is, I know it's a very familiar person from our own state. Of course, I'm really thrilled that I'm also part of this state, and also he's a social entrepreneur and the father of a white revolution, Dr. Verghese Kurian, late Dr. Verghese Kurian. He said that the India's place in the sun would come from the partnership between wisdom of its rural people and skill of its professionals. I think very profound statement, and it is not just a statement, but he went ahead and proved and changed the entire fabric of India's white revolution, which began early on, since independence. I think taking the same vision forward, there is a responsibility from each of us. Maybe it begins with the government to give the conducive environment to get the solutions on the ground. There are private telecom operators, as my previous speaker, Mr. Jacob, told. There need to be a participation between the telecom vendors. Then there are the product and the technology vendors like us, and my colleague, my friend Vimal is sitting here. How we all come together to build this great ambition of digitizing India and taking India to the next level. Of course, this is Juniper's stated motto. Juniper was founded by an Indian, Dr. Pradeep Sindhu, and he is still the serving chairman of the board and the chief technology officer. With this vision in mind, connecting the world, or connect everything and empower everyone. I think that's continued to be Juniper's vision. And I don't need to explain what connectivity can bring to the social fabric. We have seen the Facebook generation, and we have seen many other generation which is coming up, which have instant information across the globe, and we are kind of globally now we kind of one, which is envisaged in the many centuries ago, and with connectivity, and that has brought people together. Imagine if the knowledge base collectively, as Dr. Kurian said, the wisdom of the rural people across the globe can be brought together under one platform. It is happening. And we have a great opportunity to take this stride and move forward, which will rethink our education, revolutionize e-commerce, and enable various ecosystems. This data, I think you've seen in the previous slide, but my point which I want to make, we are one of the countries have the largest tele-density or biggest tele-density, both urban and rural. Of course, the rural need to catch up. I think private players are also playing a role in building connectivity in the rural area. There are several impediments, but I think they are step by step they are moving forward. But in contrast, if you see the fixed broadband connection, probably India stands at 137 in the world list. We are at 137 odd. That was the late 2014 data. I think we have a long way to go to build this fixed broadband infrastructure. One of the major concerns is, of course, availability of fiber and regulatory framework to get fiber across all part of the thing. I think the vision of BharatNet to connect to 250,000 villages is actually very tall order. I think it began way back in 2011, and we haven't made too much progress in that area. I think it's a great opportunity to go and connect our villages using very high-speed fibers. So, because the topic is also around NOF, and I would say there are many things which India can be proud of, like our other services, like our national knowledge network, which Juniper is also part of that. And there are a lot of success stories. I'm sure there are people from IT Mission, NII, and others sitting here. We can witness that some of the successful deployments of national knowledge network and statewide area networks in Kerala can boast of one of the most vibrant statewide area networks here, and several other states can boast of the same. And those have really connected people together, government to the citizens together, and many of the services could be rolled out easily. But at the same time, I think where we haven't moved forward is on connecting the villages on very high-speed internet. A typical architecture that is shown here, because we come from the technology background, this is similar to a telecom network, building hierarchical network of core aggregation access type of networks. Because when we actually build this network has to live for several decades probably, and the investment that we're doing today, based on the technologies available, has to live for several decades. So I think our view is that there has to be a real good thought process in selection of access technologies, and also the kind of technology that is used building the end-to-end ecosystem here. Some technology options, keeping the real requirement of a telecom operator or a large-scale mission-critical network in place. Reliability is one of the key things. I'm not going into details of that because we know that when these equipments get deployed across very many areas which may not have the right cooling environment or temperature requirements and things like that. So the reliability in a deployment scenario where I think Mr. Jacob would know that when we do cell site deployments, the kind of environment that we deal with, that we are doing with one of the largest telecom players today. So that is one area. Scalability is, again, we know that the bandwidth is increasing by the day. Today the overall internet bandwidth globally stands at around 1 zettabyte, which is around 10 to the power 21. And it's going to go, I think it's going to double in the next 3 years. It's going to double in 3 years. That's the amount of data. Once you give access to this connectivity and to internet, we see that the amount of data keep increasing. So scalability is a key thing. Service oriented, that should be adaptable to many services. Security is a key element. there has to be a point of interconnect that once this fiber layout is done, the service providers, private operators, cable operators, and many others can actually ride on top of this one of the critical assets, which is the fiber on the ground. Of course, quality of service, multi-tenancy, consolidating the existing network, and carrier-grade operation support system, etc. Some technologies which people evaluate on, I know from the point of view of BharatNet and NOF, and the technology has been re-evaluated. I think from a gigabit GPON there is a migration from GPON to MPLS-based technologies, and there is also a revision of budget, which I don't know, maybe some of the panelists may come across. Revision of budget based on the revision of technologies. One of the options is, of course, Ethernet. This is not a statement of of a technology selection, but Ethernet has this characteristic of lowest cost per bit, and it is really the speeds and the performance of Ethernet have been increasing tremendously. I think we are standing today on a 400 gig Ethernet port. So few things around Ethernet. That could be one technology which could be used. The other technology under debate is MPLS TP. That's another technology which is under discussion. There are many technologies available on the Ethernet framework which can give you 10 gig in the access rings in a hardened platform. I think that is one great technology to go after. And also from the industry point of view, what really is happening is one universal protocol, which is TCP/IP, which has changed the face of Internet. And we have seen several technologies over many years. TCP/IP certainly is one. And then later on, we have seen that how to increase the performance. Then all these silicons, the merchant silicons or the proprietary custom silicons, which came into play, and then started building on the packet forwarding engines. I think Juniper as a company was born into this era, where we started building hardware-based packet forwarding engines that Internet could scale from maybe megabits to maybe gigabit to zettabyte, and very high speed. And that is the technology which is getting prevalent now. And the third piece, which has to come into life, is automation. When actually having the scale and complexity, what is most important is how do you automate all these technologies together. I think the biggest discussion which is happening in the telecom world, apart from India, could be slightly different on, we have access issues, spectrum issues and things like that, but world over, I think the Mobile World Congress is going to take place in the next couple of weeks. One of the key discussion is on network function virtualization and how services can be given through mobile ecosystem. I think which will eventually, if the content can be moved closer to the user, whether it's in the government type of networks or in the context of BharatNet, I think that will give you the best user experience. I think there are technologies which are scaling into that, which work into the automation space. A few things what Juniper is doing, I've not spent much time here. Probably one of the largest telecom backbone devices based on our custom silicon, which runs into multi-terabits. And also building data centers with very high scale deployments. We build some of the largest data centers and public data centers across the globe. And also security, probably one of the highest performing security devices, which is guarding most of the GI, the telecom security, mobile interconnecting areas. And this is also an automation platform, which will actually, when you build the network, how do you really create a Google map out of your network? I think this particular product from our side, Northstar, is actually is a Google map of networks, which will actually move packets based on intelligence. So in a nutshell, the network would look like this. You have a large optical backbones being built, and then you have several access technologies, whether it's Ethernet or TMPLS, etc., will actually be followed through with the real traffic engineering. Of course, we have to tread with caution that we have had a very long debate on net neutrality and what can be done around the internet, giving equal access to internet. Of course, we can't do too many manipulation of packets here, keeping in the spirit of net neutrality, but I think from the internet standpoint, but I think the BharatNet or the NOFN that is envisaged has not just internet, but there are several other services and also a multi-tenant system where cable operators and others can also play in. So traffic engineering is a very important piece. Quickly, three areas which need to be looked at from a technology standpoint: efficiency, elasticity, and programmability. That will actually hinge back to the same thing, that once you build it, it needs to live for several decades. The technology has to evolve. So in summary, one of the key areas that we look at is performance, so that it can grow the rate at which the internet is growing. And the second piece is, of course, simplicity. I showed up some pictures on automation, where that you don't need to really have a manual intervention, like as much as what Google Map could do in your navigation. There are technologies available in the network space which can actually very intelligently move packets based on the network conditions. And of course, security, probably one of the paramount things, especially when you have a lot of critical information which is flowing through the network, more than the informational security, which probably would have been taken care of in the data center or with the data origin. I think the network itself could be on attack. We have seen attacks on power grids and attacks on several other installations. Once digital platforms become the lifeline of the society, if somebody can launch an attack on that platform, could actually bring down the whole deployments. We built some of the largest data centers and public data centers across the globe. And also the security, probably one of the highest performing security devices, which is guarding most of the GI, the telecom security, mobile interconnecting areas. And this is also an automation platform, which will actually, when you build a network, how do you really create a Google map out of your network? I think this particular product from our side, North Star, is actually is a Google map of networks, which will actually move packets based on intelligence. So in a nutshell, the network would look like this. You have a large optical backbones being built, and then you have several access technologies, whether it's Ethernet or TMPLS, etc., will actually be followed through with the real traffic engineering. Of course, we have to tread with caution that we have had a very long debate on net neutrality and what can be done around the internet, giving equal access to internet. Of course, we can't do too many manipulation of packets here, keeping in the spirit of net neutrality, but I think from the internet standpoint, but I think the BharatNet or the NOFN that is envisaged has not just internet, but there are several other services and also a multi-tenant system where cable operators and others can also play in. So traffic engineering is a very important piece. Quickly, three areas which need to be looked at from a technology standpoint: efficiency, elasticity, and programmability. That will actually hinge back to the same thing, that once you build it, it needs to live for several decades. The technology has to evolve. So in summary, one of the key areas that we look at is performance, so that it can grow the rate at which the internet is growing. And the second piece is, of course, simplicity. I showed up some pictures on automation, where that you don't need to really have a manual intervention, like as much as what Google Map could do in your navigation. There are technologies available in the network space which can actually very intelligently move packets based on the network conditions. And of course, security, probably one of the paramount things, especially when you have a lot of critical information which is flowing through the network, more than the informational security, which probably would have been taken care of in the data center or with the data origin. I think the network itself could be on attack. We have seen attacks on power grids and attacks on several other installations. Once digital platforms become the lifeline of the society, if somebody can launch an attack on the platform, could actually bring down the whole fabric, and it could be disastrous. It could be like a cyber war, so to speak. So, ground up look at on a network security is a very important thing. And of course, openness. There's tendency, and I'm also culpable for that. Last time. Is that to close
to have a closed system so that you can sell more gears into the same network over and over and over. You can probably milk that network forever. But I think gone are the days. I know if I can speak of, if you look at Amazon, Facebook, and people like that, they don't buy a branded switch. They call something called the white label switches, which is probably an open standard hardware, and they run their software assets on top of that. So the world of network is opening up. There are selective uses of gears, like especially in battlefield network and things like that. We can't take too much of risk in openness. But when it comes to internet, if net neutrality is so vehemently fought that there shouldn't be any preferential access to anybody, then the network equipments also should come into that openness. It should actually, I think it's my personal view, that network equipment cannot be held, cannot hold the network captive. It should be open. It should be open and open for several people to innovate and establish. So, in closing, our mission in Juniper is to connect everything and empower everyone, which includes, of course, India is a key country for us. We have over 3,000 plus research engineers sitting in Bangalore. We also have selective programs going on with Government of India for critical infrastructures for custom security and several areas. I think we are committed to this, and we want to bring probably the most affordable hardware solution, hardware-software solution, and the most open solution to the market to take India to the next generation. Thank you so much.